Welcome to another hands-on video. In this video, we are basically developing an ERC721 token with built-in secondary sales revenue calculation for OpenSea, Rarible and Mintable. This is how we go about this. First of all, we spend a brief moment setting up a dev environment. Then we start with the minimal ERC721 token. Then we add in minting and ownable methods for OpenSea. Then we add in the Rarible royalties functionality, so the Rarible DAO recognizes those. Then we add in ERC721 NFT royalty standard functionality. Then we add in unit tests for those. And then we also briefly talk about the TokenURI, so it's actually a fully functioning ERC721 token. One word of caution, I'm trying to be as accurate as possible with the videos. We're actually using a very similar token in production for project STZ, but as always, do your own research and do a full audit of your tokens before you deploy them. This video is for educational purposes only. So let's get started. In this video, I'm using Windows, but I will use WSL2 with an Ubuntu 20.04. The reason is I wanted to make this setup as cross-platform as possible. So first of all, we create a new folder that's empty. And then we start Visual Studio Code with that new folder. Let's make this a bit bigger. First, you need to install npm and Node.js. I have them already installed. Those are the Node and npm versions I have. Then you need to install Truffle with npm install-g Truffle. I like to install Truffle globally so I can access it for every project. If you get an error message like this one, and chances are you will, you have a few options to fix it. I usually don't like to run npm using sudo, so I will fix it without compromising the ownership of the files. Set the npm global directory using these official workarounds proposed by the Node help page itself. Then I'm trying to reinstall Truffle and it works. Now we initialize an empty Truffle project using Truffle Init. What you get is the default folder structure for a Truffle project. But we also want to add in other npm packages. So I will just initialize a new package.json file with npm init-y with the default values. I do not care for now about any namings or licenses or anything of that. Then we install the OpenZeppelin smart contracts. OpenZeppelin provides a set of audited, industry standard, reusable smart contracts. I do recommend using them, or at least have a look at the architecture. npm install OpenZeppelin/contracts does the trick. Now we have different contracts in the folder. We also have all kinds of tokens. We need the ERC721 token from there. Let's create a new smart contract. I'll just name this minimal ERC721. SPDX license identifier, pragmaline, contract. One thing I see here that Solidity syntax highlighting isn't working. I'm starting Visual Studio Code for the first time in a WSL environment. I can recommend the Solidity Visual Auditor plugin, which needs to be installed here for WSL as well. What you see here that we are writing the contracts for Solidity 08X, which is the same version that OpenZeppelin contracts are written for. Let's import the contracts and use them in our contract. We need the ERC721 contract and extend it from our own smart contracts. Then we initialize it in the constructor. Now let's simply compile those using Truffle. Let's see what happens. Truffle comes still with the Solidity compiler version 0516 by default. We can easily change this in the truffle-config.js file. On the bottom, you find the Solidity configuration. Simply uncomment the part that you need. I also recommend enabling the optimizer, as it produces smaller files to deploy, meaning less gas costs. I see there's a small typo in there. Let's fix that and recompile. Works. Let's create a small migrations file for our smart contract. Basically, we can copy the one that's here already and rename it. This will allow us to deploy the smart contract. If this sounds unfamiliar to you, then check out the links in the description below to a full course on Solidity and Truffle. Now we can start the developer console. This will give us 10 accounts to play with. We can simply type in migrate, and Truffle will deploy the smart contracts using the migrations file onto the developer network. Perfect, everything is deployed. Now we can use it with the built-in JavaScript console. We can instantiate the token. If you use the function completion by using the tab key, you can see the available functions from the token. One thing that we're missing here is the mint functionality. You can do pretty much anything, but not minting. Our token is useless. Let's add the minting functions. At the same time, let's also add the ownable functionality. OpenSea lets you set secondary sales royalties if you are the owner of an ERC721 smart contract. This is the first learning that we had here. You don't need to be the owner of the tokens. You need to have the same address that the owner function returns. Let me show you this in a second how that's done. First, let's add the access control contract from OpenZeppelin. Let's have a look what changed. Instantiate a second version of the token. You get a new owner function. The old token doesn't have it. If I call it, I get my own address. The first index from the accounts array. Perfect. Now let's add a minting functionality. For this to work, you need to return the token ID somehow. I'm going to use the token counter function built into the OpenZeppelin smart contracts. Then we can define the mint function. It takes the address we're minting to. It also uses the new Ownable contracts. They have a modifier. I'll show you in a second that comes in handy if you've never seen that. I have to admit, I didn't come up with this myself. I got it from the token preset that's available. Look into the token preset or even use it right out of the box if you just need, for example, the burn functionality and so on. And the only owner modifier is from the Ownable Solidity contract. Let's deploy this and give it a try. We define a new instance and we mint a token. Let's check the balance. It returns a big number object. Let's convert that into a regular number, and the number is 1. Next, we add in the Rarible royalties. They are a bit tricky. Rarible expects to call a function in a certain way. From their own repository, you can see the Rarible's v2 has a function called getRarible v2 royalties. That's the interface we need to mimic. The contracts from Rarible are written for solidity smaller than 0.8, so we can't directly import and use them, but we can do almost. So let's use the same folder structure and everything, so it will be easy to replace the ones that we are writing here once Rarible follows with a new solidity version. First, recreate the folder structure. Then we add the files one by one. Rarible, royalties, contracts, royalties v2.sol, and remove the AB coder line and up the version number. That's basically all we need to do. Redo the same with the rest of the files for royalties v2. The lib part, the royalties v2 imp, and the abstract royalties. Don't forget to change the version numbers there as well. One last thing is the lib royalties v2. At the end, you should end up with this folder structure. Now we need to bring this into our contract, so let's import the contracts we need. The royalties v2 impl, the lib part, the lib royalties v2, extend our contract from royalties v2 implementation. So impl. So, but how do we add the royalties? That's a bit tricky. Let's create a new function, set royalties. We need to set royalties for a token ID, someone who receives the royalties and percentage basis points. The Rarible royalties expect a lib part array. Then we can call save royalties basically from the parent contract. The Rarible DAO also expects that the standard support interface function returns true on the byte 4 representation of get Rarible v2 royalties. So let's give this a test run. Whoop, typo. Okay. Try again. Okay. The thing I did differently is to make the address payable. And you'll see in a second why. Let's fix this and then redeploy the smart contract. This time it works. Let's instantiate a new version and then mint one token. Then set the royalties. You can see here we set 10%, but we have to input 1,000 because it's percentage basis points. Let's check if we can get the royalties back. Get Rarible v2 royalties for token 0 works. And the interface also returns true. Perfect. Let's add the ERC721 then. As you can see here on their official website, they too expect a certain interface to be supported. That is the interface to the function that calculates the royalties from a specific sales amount, named royalty info. Let's add this function to our smart contract. Do some formatting, that it doesn't look so messy. Actually, close the rest of the other files. We don't need them anymore. Okay, now we can work. What I'd like to do here is to get the royalties directly from the Rarible royalties we saved before. Then we simply calculate the commission based on the sales price if anything was set. If nothing was set, then return 0. Let's deploy this and give it a try. Instantiate a new token. Mint one token. Set the royalties for the token. Get the Rarible royalties, still works. Get the royalties info on a specific sales price. Perfect, the math adds up. Now, as with every critical component, let's add a simple unit test in Truffle. We're not going all in through this video, but let's cover at least 3 basic scenarios: minting, setting royalties for Rarible, and Mintable. First, we're going to test the minting. Writing unit tests here is basically the same as using the Truffle developer console. One thing that is different from the normal chai, we are using contract, not describe, but the rest is pretty similar. Let's test this. Works. Let's add the other 2 tests, setting the royalties and getting the royalties. For setting the royalties, we again instantiate a token, call the setRoyalties function, and then assert if the royalties we get back match the values we put in. For the ERC721 royalties, we already have them set in the previous test case, so we just test if the royalties match the sales amount. Specifically, 10% of the sales amount here, or 10K out of 100K. Let's run the test. Up, a small mistake. It's called get Rarible v2 royalties. Let's run the test again. Another small typo, it's account, not address. This time it works fine. Perfect. The last thing we have to do is to add functionality that an actual TokenURI is returned. This is the JSON file for the metadata that OpenSea, Rarible, and Mintable read out to display additional information about each NFT. That means each token ID get their own metadata file. The problem is, if you look at the OpenZeppelin ERC721 token, if the base URI is empty, the token URI is empty too. So we have to add a base URI to our token. Let's add the function. You obviously have to enter your own hostname here. Let's try this as well. Instantiate the token. Mint. And get the token URI. Seems to work. Perfect. Well, if that was a bit too fast for you, check out Ethereum-Blockchain-Developer.com. There you can find a full rundown of this video as well. The link is in the description below. We used this very technique in our own contracts we did for project STC, a novel NFT which combines the physical and digital world. Also, we're starting a new project with blockonair.com, where we want to give cool blockchain projects a platform to present themselves through a coding interview with us. Check out the links. Thanks for watching. If you made it so far, consider subscribing. I hope I can welcome you in one of my next videos.